Okay, so we have today Zach. He's the CEO of Ultravox. It's really nice to have here him. It was at the first time when I have the challenge to contact him. It was like, oh my god, I'm talking to the CEO of Ultravox. So let's try to have a podcast. Let's try to have a small chat so everyone can see what they are doing because it's wonderful. I following them from like 1 year and a half, more or less, and it's amazing all the work they are doing. They are super focused on always getting better. I'm always following there in LinkedIn, also in Discord. They are super all the time answering all kind of questions. So, Zach, welcome.
Thank you. Yeah, thanks. Yeah, I remember our first chat maybe back in like early 2025, maybe even 2024. So it's been a while. Yeah.
Exactly. Okay, so Zach, how did the idea for Ultravox come about?
Mm. Yeah. Well, I think that we started. I mean, as a company, we started working on like LLMs back in 2022. So kind of before the launch of ChatGPT and other things. And so we've been working in large language models for quite a while. And one of the things that we felt very early on is that large language models are very, very good at natural language. Like they're very good at like, just this style of communication back and forth and in regular English and any language really. And um, and so we thought, you know, wouldn't it be cool if you could turn this into like a like voice to voice interaction? Because, we've people have been talking about like talking with your computer like a human for a long time, like 20, 30 years. We had Siri, we have Google Assistant, we have all these things, but all of them were quite bad, right? They weren't natural. And we thought, oh, maybe this is going to be possible to do it on top of large language models. And so
Oh, wow.
we started off by building actually what I would say is like now the very common components pipeline, right? Where audio comes in, you convert it into text, and then from the text, from the audio, you give the text to the LLM, and then you take and then that goes to a TTS engine. And I think this is very common now. Like a lot of platforms offer this. Like this is how 11 Labs work. This is how Cartesia works. This is how like Vapi, like all of them kind of work this way. I think our big realization in 2023 was that this is not going to work. It's never going to get you to a human level conversation because the minute you convert a bunch of speech into text, you lose all kinds of signals that we as humans use to make meaning in conversation. And so it just felt like the wrong direction. And so we felt like the right direction was you need to teach the model to learn to understand human speech directly. And we needed to teach it to understand what human dialogue sounded like. The text thing is a nice shortcut, but it ultimately is never going to get you fully natural conversations. And so it was sort of from that idea that Ultravox was born, which is, how do we train a model to understand speech naturally as humans do? That's kind of the origin story.
Okay. What were the most the challenges that you were facing at the beginning? Because at the beginning, I guess you are one of the first ones that are starting to use all these voice agents. So tell us about the challenges that you face.
I mean, yeah, there's an endless number of challenges, and there is still an endless number of challenges. I think that for us as a company, one of the hardest things was that by background, actually, we're like I am not a model builder. By background, like I am more of an applied person, and most of our team was applied. And so once we realized this was the right direction, we had to go, learn how to become model builders, and then we had to build a new team around that. So I think that's one challenge. I think the other challenges are really around um, the question is how do you actually get a model to understand human speech? And how do you do so in a way that does not result in a dumb model? So I think this is always the challenge in speech land right now. is that in order to have an effective voice agent, you need the model to be smart, but you also need the model to be fast. And so I think that there's a tension here. And so if you look at, for example, real time from OpenAI, their speech model, it's a good it has a good conversational experience, but it's really quite dumb. Its tool calling is not very good. Its instruction following is not very good. And why is that? Well, it turns out that when you go to like train the model to understand speech, there's lots of choices you have to make in how you build those models. And all of those choices come with different trade-offs. And I think that for a lot of cases, there's like this tension. And so do you remember Moshi, when Moshi came out from like that speech-to-speech experiment from Kyutai Labs in France? I don't know if you saw that, Moshi.
No, I didn't.
It's worth looking at, MOSHI. It was an example of a very, very fast full duplex model. But unfortunately, it was just so stupid. And so like, there's always a tension here. And so the hardest thing for us was trying to figure out, how do you train the model to understand speech while also letting it continue to be really smart? And it took us a lot of trial and error to figure out, I think, how to do that. To I think where we are now with Ultravox 0.7, which is like the smartest speech model you can find on the market, and the fastest. But that took us, I mean, two and a half years to figure out. So it's just a lot of hard problems in model building land. And then once you build the model, you have to run the model. So we run all of the models on our own compute. And so you've got to solve inference problems at scale around the globe. So there's all kinds of interesting challenges out there. But those are some of the big ones.
Yeah, because, for example, the latency in Ultravox is super fast. I mean, we are here in Spain. I guess the servers are there in US. And the latency is amazing. It's like, it's real time. Yeah, it's real time. It's completely real time.
Yeah, I think like any company, we also build on the shoulders of giants who came before us, who have done really remarkable work, I think, So for example, like WebRTC is a really great technology that allows us to send audio packets, audio bytes down to clients directly really fast. And that was born, over the last 20 years from people that are really smart. And then on the inference side, there's like, we've done a lot of work there, but all the people in the open source community launched VLLM. And so like, yes, I think we've done a lot of work, but also, the community at large has done a lot of work, and we've been able to kind of take that and build on top of it. And I think that the thing that we've always felt is that we can never compromise on speed. And so everything we do, we look at through the lens of how fast can I make this? How fast can I make this? Like, oh, that's too slow. How fast can I make it? And if I don't see a path to making it fast, then I don't do it, right? We have to find another way.
Okay, so for you, the most important thing for the model is to be intelligent and fast, right?
Exactly. And it turns out that like actually getting both of those is extremely difficult. And I don't think a lot of people actually appreciate how hard this is, because if you think about it, if you're not using Ultravox, you're probably using a text model. And if you're using a text model, you're probably using a text model from almost 18 months ago. You're probably using, like, let's say you want to use an OpenAI model, right? You're probably using GPT-4o or GPT 4.1. But these are really old models. They're not even nearly as smart as like modern models. But the problem is that all modern models are thinking models. And so they take longer to produce tokens. And so it feels like all of these voice agents that are building on these old text-based models are stuck in the past. And they're stuck in the past because that's the only model they can use that's fast enough to not be terribly slow. And I think so it's actually fast and smart is actually a really difficult combination to achieve.
I can see. And Ultravox in that way, it's amazing for those.
Thank you. Yeah, we spent a lot of time on it. So yeah, we're proud of it.
I can guess. So Ultravox bets on speech-to-speech models. But why did you decide to take this more difficult technical path instead of the traditional speech-to-text approach, no?
Oh, I mean, I would say like life is short, so you should go solve interesting problems.
I love
Like, like I said at the beginning, I do think that the text to speech or speech to text, text to speech path is dead over the long run. It just is obviously the wrong approach. And almost every criticism that people talk about speech to speech models with is just wrong. Like they just misunderstand how the models work and what you can do. And so ultimately, I look at it as like inevitably that everyone will be on speech to speech. And so I'd rather be on the forefront than on the back, personally. I think it's harder. And so I think you can build a really great business on the other thing. But for me, life is short. We should be at the forefront. We should solve interesting problems. We should like challenge ourselves. We should build great technology that we're proud of. And that was the right path to do that.
Yeah, because you were competing against, for example, Google, OpenAI, so of course retail, Papi, and you said, okay, let's do it. Amazing.
Yeah, why not, right? I think, at the time that we started, no one else was really building speech models. And so it's not like I decided I'm going to go head to head with OpenAI and Google. It just so happened that no one else was building this. And so I wanted to launch, I thought speech to speech was the future, and obviously the right answer. I didn't want to productionize the component stack. I just was like, nah, we should go. And there was no one else to go to. It's like, we'll build it ourselves. And now, of course, Gemini Live has something, OpenAI has something. But I think we do remarkably well against them for being 1/1000th of their size. And so I'm if nothing else, I'm proud of what we've accomplished. So.
Really. Okay, so there will be people watching this video and wondering if they can implement this in their own business. I mean, what specific types of businesses do you recommend Ultravox for today? Is it only for massive call centers, or is it also suitable for small local businesses?
Yeah, I think it's a good question. I think that I think right now our customers range everywhere from like very, very small businesses, startups that are just getting started, to like very scaled multinational companies. And so I do think that we are probably slightly more technical oriented than, let's say, a Vapi or a retail. And so it tends to be that like the startups who use us tend to have like engineers, and those engineers will build against us. We're not as much designed, I would say, for like the, if I'm just like a sole proprietor and I run like a 1 or 2 person company and I want to build a phone agent to answer the phone call, like we ourselves, like you could maybe do it, but you have to be a little bit technical to kind of put all the pieces together. I think we've come a long way in allowing you to design your agent, build your agent, prompt your agent, test your agent, like all inside of the platform. But there's a little bit of work to do to still connect it into like your telephony system, as I think you know, and like your phone calling system. And so, and I think this is just like by design for us. We tend to focus a little bit lower in the stack because we do so much like in API land and stuff like that. But that said, like we have customers who, even though I tell them, hey, we're going to be a little bit complicated, they go for it anyway because I think they really like the end experience. And so, yeah, that's kind of my answer. But you can also use Ultravox, let's say, inside of LiveKit agents. You can use Ultravox inside of Pipecast. And so you don't necessarily have to go through our systems if you don't want to. I mean, you will go through our systems, but like LiveKit and Pipecast have done some nice abstractions to make it easier for you. And so that's also another great route for people that like that are a little bit less technical, let's say.
Even if you have like N8 and basic knowledge, you can even connect Ultravox with
That's right,
Google,
for sure.
like that.
For sure. Because at the end of the day, like it's actually quite simple, I would say, from an actual implementation standpoint. Like you create a request to create a call, like, then we handle all the complexity of actually creating the call, mapping it, keeping it fast. We do all of that. All you have to do is basically say, hey, create the call, and then pass it to Twilio, for example, or pass it to your carrier of choice. So it's not bad at all. It's just like it requires that little bit of an innate in step. Correct.
Yeah, and for example, Zach, one of the biggest issues in voice AI is latency, because how have you achieved that near instant response
Mm,
speed that mimics a real human conversation? Because if you realize
mm.
the human conversation, it's amazing. It's really real in even in Spanish, because it's our language.
Yeah.
It's super real. How did you get that? How did you come up with that idea?
Well, I think everyone's always in voice AI is trying to drive down latency. But I think that here is like the simple truth is that the number one driver of latency is on the model side, right? I mean, in any system, it tends to be that the biggest piece is the slowest piece. And so if you think about any stack, even if, let's say forget about Ultravox for a standpoint, and you just have the speech to text, LLM, text to speech path. Some people think that like the latency is coming from the text to speech or the speech to text side and the text to speech side. Like it is a little bit, but it's certainly not the largest cause of your latency, right? ASR is relatively fast, and TTS can also be relatively fast. The problem is this thing in the middle that most people don't control. And so in most cases, when people go to build voice agents, they're outsourcing the running of their model to someone else, right? And so let's say that you use the OpenAI API, and you go to make a request to basically say, the user says, "Hi, how are you?" And you want the model to be like, "I'm great. How are you today?" Well, like you send that request up to the OpenAI API. But here's the problem. The OpenAI APIs are not optimized for real-time latency. And so what actually happens in all these cases is that you are stuck in a queue of a bunch of other people who are asking the OpenAI API for something. And most of them, and OpenAI is trying to do its best to like feed those and serve, and they're trying to keep their GPUs full. And what that means is that a lot of time you're just spent waiting. And this is why for most people, their voice agents are sometimes fast, but oftentimes are not. And it's because you're just stuck in a queue waiting for someone else to run the model on someone else's hardware, on someone else's infrastructure somewhere else. We recognized this very early and said, there's no way that's ever going to work. And so, I said, so not only do we build the model and train it, and we make it open source, of course, right? So all of our models are open weight, so anyone can go run them. But we also we run the infrastructure ourselves. And so we buy the GPUs, we rent the GPUs around the globe in data centers. We run the inference stack that runs them. And the whole thing has been tuned for latency. And that means there's all kinds of like trade-offs. So for example, people talk a lot about concurrency, right? And people want to be able to have lots of concurrent calls and stuff like that. But but our question is always like, how do I balance concurrency with speed? And so, we give we expose a lot of these details, right? And we do a lot of tricks, I will say, like at the inference layer, to keep your performance really, really fast. But I would say the key thing is that we don't have an ASR step because the model understands speech directly. So we can skip that nonsense completely. The second thing is that we're running the model ourselves and the whole thing is tuned for incredible speed and performance. And I think that works really well at this point. We spent a lot of time on inference and performance of the system. And so ultimately what matters to an end customer is that when you talk to Ultravox, it talks back really fast. And that's because the whole system is optimized to do that.
Wow. And like for those, because there will be also some advanced users that they're really good on coding and they're really good coders. For more advanced users who have been using Ultravox for a while, for example, what do you recommend they do to ensure the calls get better and better in quality, in terms of quality?
Yeah, what's funny is like, I don't think programming is useful at all in improving the quality of calls, right? I think that because the programming is actually very simple. What matters is actually the prompting and what you give to the model. And I think that anyone can do that. I think that, but most people are not great prompt writers, is my take. They don't spend a lot of time thinking about their prompt. And I think that the way I always, it's like, I describe it to someone is that, like, imagine that you met a complete stranger on the street. You had never interacted with them before. And you had to write a piece of guidance for them. And that stranger was now going to run your call center. Okay. What would you give them? Like, what are the instructions that you would give them to do that? And like, imagine that you're writing for a human you've never met before, you've never talked to them before, you have no idea. And every time a call comes in, their brain is reset, right? Because that's how models work. They have no continuous learning like we do as humans. And so I think what most people end up doing is quickly trying to write the prompt, and they make a lot of assumptions in what the model knows. And you should never make assumptions in what the model knows. And this is why most people, like, as you have more and more calls, you realize all of these edge cases that the model is not doing well on. And I think that what they're not realizing is that anything you don't specify in your prompt, like, the model doesn't know how to handle. Just like that human off the street that you've never met before that has to answer your thing, if you don't give them guidance, they also don't know what to do. So they can either say, I don't know, or they can make something up. And models almost always make something up when they don't know, right? That's just the nature of LLMs. They hallucinate details into existence that they don't know. And so the way that you get better has nothing to do with programming. It has to do with, like, looking at the calls that are happening and evaluating them and trying to figure out where are the gaps in performance, and then figuring out how do you fill those gaps. And there's all kinds of automated testing for this as well these days. There's like Hamming AI, Sakura, Koval. There's a number of them, and they're helpful. But I will say nothing is as helpful as you running through your calls and figuring, and then, like, looking at your prompt and figuring out, like, why is it not doing what I want? And the beautiful thing is that you don't need any kind of programming background to be useful here. You just need the ability to speak whatever language you want the model to speak. English, Spanish, Portuguese, French, Mandarin, doesn't really matter. And I think that's what's great, is you don't need any programming to do this.
And how do you start? Because prompting is for me also the most important thing in a voice agent. How could you?
And everything AI related right now, prompting is it's all prompting. We just say it's prompting all the way down. It's prompts on prompts on prompts on prompts on prompts. That's all it is.
Okay, so how would you extract the perfect prompt for you? I mean, how would you start to structure the prompt?
I don't know. I've never written the perfect prompt, so I can't tell you. We only edit our way to greatness, to perfection. But I think that it's an interesting question. There have been so many great guides written on prompt writing. I'm trying to decide what I have to add. I think that good writing is good thinking in general. And so in order to write clearly, we have to think clearly. And I think most people, they tend to, I think of, like, I don't know. For me, I think about when I was in school, and the teachers would have you write these essays. And you would write, like, a rough draft first. And then you would think about, okay, what am I trying to say? What do I want this model to do? And you kind of sketch it out first. And then you write, like, a more detailed draft. And then you edit it. And then you, like, ultimately come up with, like, these increasingly, like, clear essays that you would write in school. I view prompt writing as very similar. Like, you have to know, okay, what are my goals for the agent? Okay, who is my agent? What are the characteristics that they have? What do they know about the world that I want them to know about? What is their job, right? What is your task that you've been assigned? Is it to collect information? Is it to be, like, what a thing? And how can I sort of, like, for each of those things that it has, am I making sure I'm being clear for each of those things? And then tools, for example, tools are also prompting. Like, the name of the tool is prompting. So, for example, like, the description for the tool is prompting. The response that comes back from the tool, from your system, is prompting, because the model will use all of this to try and make sense of what to do next. And like, I think a lot of people will end up calling their tool like, check thing. Well, how is the model supposed to know what check thing means? It has no idea. So it's not going to use that tool correctly. Or like in the tool response, it'll be like, check the thing. And again, the model's like, well, I don't know what the thing is, so that's not helpful to me. As opposed to, let's imagine like check users' account information, right? And so, okay, and the model's like, I know what to do with that. And then it returns back. And then the tool response is, here's what I found. It says, here's what I found for the customer, name, Sergio, location, Spain. You know what I mean? Like, this is the type of thing that people oftentimes I see get wrong every single day. Before this, we had to make this meeting run a little bit later than scheduled, right? We pushed back 30 minutes. Why? Because I was on a call with a customer and I was reviewing their prompts and they're making all these mistakes. The model had no idea what to do. And so I just can't emphasize enough that like you should print out your prompt and go give it to someone who has no idea what the hell you're trying to do and see if they can make sense of what you're asking of them. And if they're confused, I guarantee the model's going to be confused. And it's not, the goal is not, can they eventually figure it out? No, the goal is like, can they read it and know exactly what to do immediately? And if not, then you have a bad prompt and you should try again. That's kind of my rough litmus test. Is like, if you give it to a stranger and they don't immediately know what the hell to do, bad prompt, throw it away, try again. That's like my take.
Okay, another question about prompting. It's, for example, when you want the agent to remember everything, like the most important thing, will you consider put it in the first lines and also at the end of the prompt, and the middle is like is running out of memory? What do you think about this theory?
Yeah, I don't think it's a theory. I think this is very proven and clear. Is that that basically, I mean, the mechanism in the model is attention, and so we basically say, how well does the model attend to various bits in the prompt? And there's no denying that the model attends best to the things at the front and end of the prompt. So in general, yes, like the things in the middle are more likely to be forgotten. It's also the case that there is a very clear relationship between the length of the prompt and how effective you can be. And so tight writing matters because you're trying to be as clear as possible and be as succinct as possible. Because let's say you have a 50,000 token prompt. The model's not going to perform well against that. It's just very, very hard for the model to do well against it. Any model right now is still not great at that. And so it's certainly the case that the start and end is probably good places. But it's also slightly more nuanced than that. But that requires understanding like a little bit like what the shape of the thing is. But yes, in general speaking, the last thing that the model sees will influence it very heavily.
Okay. What would you say the length of prompt? What would you think is the ideal, more or less, around a range?
I mean, like, I think your goal should be to keep under 8,000 tokens.
Okay.
Like, I think that's a good number. I think that like, if you can do it in 2,000, fantastic. But like, I think if you start to get over 8 to 10,000, I think you should reflect on whether or not you can't rewrite this into a smaller prompt. I definitely see performance degradation around that mark. And I certainly think for voice agents in particular, because voice agents, as you know, like you have a lot of rapid back and forth. Like I speak, agent speaks, I speak, agent speak, I speak, agent. So your conversation history grows quite quickly. And most models aren't actually super well trained for handling that well. And so the tighter we can make our prompts, the better. But I would say if you can do it in 4,000, fantastic. 4 to 6,000, great. But you have up to 8 to 10, I think, and get reasonable performance.
And another thing, Zach, we were trying the V0.7 version in Ultravox with my business partner, Manu.
Yeah.
We were really amazed because it was like a really good sales agent. Like we didn't say a lot, like, okay, you are a sales person, you are handling objections, you are nice, you are human. And it was
Yeah.
amazing because it started to handle objections and all this, and it was like, what the fuck? We didn't give any kind of information. How is that possible?
Yeah. Well, I think that what's happening here is the models are learning more and more. They're just getting better. And so I think that, and it kind of depends oftentimes on like what you want the agent to do. But like, let's say that you said it's a sales agent, the one you're building. I think like, I think most the models have learned pretty decently at this point, like what a good salesperson does. And so we don't need to specify all of the behaviors of a sales agent because the model itself has a good rough sense of what a sales agent is supposed to do. The thing we need to make sure to specify very clearly is the stuff that the model cannot know because it never could have learned it. Like you probably have particular policies that, you know, that not all sales agents would know, but like is what you care about. You know, for example, like, you know, we never end the phone call without like a next step identified, you know, or, and it also doesn't know the particular details of your product, your limitations, your features, your pricing. So all of that has to be embedded. But yeah, I think that what we're seeing is that we're able to get smarter and smarter models at better and better performance. And as the models get smarter, the amount of specialized prompting that you have to do should diminish over time as well. And you get more bang for your buck. Like if you go back a year and a half ago, you had to be like, you are a sales agent. Here's exactly what sales agents do. Now you can say you're a sales agent and roughly assume the model knows what that means and can drive that conversation quite well. So that's what's happening there. It's just like the models themselves are generalizing better. And because the models are generalizing better, you're getting better outcomes by default.
Okay. And do you believe it's currently possible to create an AI salesperson that effectively handles objection and sells products right now? Do you think it's possible? Or is something that we'll start to see in the future?
That's a good question. That's a good question. I don't think it's possible to build a fantastic sales agent right now. I think you can do an okay one. But like, if you think about what makes a salesperson really effective, it's their ability to kind of read the room, right? And they can feel a little bit like how to push the customer, how to change the conversation. I think, and this is why I think there's like speech-to-speech models will be the only thing that will ever work for this. There's no way to build a sales agent that's good on component sex. It's just impossible because like the things we need to read the room are in the speech, you know? Like if I'm selling you, right? That's I'm selling you Ultravox. And you're like, yeah, that sounds great. Super interesting. Yeah, I can't wait to get started on this. Like, obviously, the tone of your voice and like your facial expressions are all telling me you're not really interested. Even though your words are like, the element's like, oh, great, super excited person. But we both know that's not true. And so a good salesperson, I think, is reading those cues constantly. And they know how to push and they know how to interject. And they know how to like anticipate your needs. And I think this will be doable in the next 12 to 18 months is my guess in a really high quality way. But it's not there right now yet, including with Ultravox.
18 months?
I think 12 to 18 months, yeah, is like a reasonable timeline to expect this to be significantly better.
Because right now, AI can also feel emotions. When, for example, I'm talking to you, the AI can feel my emotions and everything right now, or it's something that we'll see in future when these AI salesperson that are developed.
Yeah, there's a version of this now, but it's not like human level yet. It's certainly that the model has some sense of what's happening and some sense of emotional sort of like testing the user, but it's not at like the level of nuance that I think you need to be super successful. Like I think that, for example, I'm a very sarcastic person by nature. I don't know if sarcasm is a big thing in Spain, but it certainly is a big thing in America, where like I will say, wow, that's a great idea. And I really mean that's a terrible idea. You know, and sarcasm is a huge part. The models are terrible at that right now. And so I think that there are, we have things to figure out still on this.
Okay, and how do you see call agents in the next 5 years from now? Will they be distinguishable from humans, or will we always know that we are talking to AI?
I don't think you're going to have any idea. I think that like there's no reason, technically speaking, that you would know that it's an AI. I think we will solve I think we will solve these problems in the 5 years. Absolutely. There's no doubt in my mind. I think that it's going to be there for sure. I think the question is like, is it 5 years or is it more like 2 years? I don't know. I would say I'm like 98% confident it's within 5 years. And I'm like 90% confident it's within the next 2.5 years.
Do you believe, for example, in Ultravox, when you are going to clone your voice, you think it's more human than a normal voice, a standard voice from Ultravox? What would you recommend? Cloning
For
your
sure.
voice?
Well,
Yeah.
well, I think that like wait. So ask your question one more time. Actually, make sure I got it.
Yeah, what would you recommend to be more human? This voice being more human? Would you go to a voice cloning in Ultravox, or more like, okay, choose a voice in Ultravox? It's right now.
I think it's gonna be about the same. I think because the underlying model technology is the same. I think the thing that's missing right now is I'm trying to think how to explain this. So if you think about what we're doing in this call right now, is that we are modifying our speech like based in context to the conversation that that's happening right now, right? So like the way you speak informs the way I speak, and also the things I've said previously is affecting how I'm talking right now. In other words, like the way we converse changes dynamically in a conversation based on context. Okay. In modeling land, the fancy thing I would say is that like my speech is conditioned on my former speech and your speech. Okay, so the way I speak is modified in context of yours. Okay, and that's what makes human conversations feel alive, is that they're constantly dynamic and they are shifting. Cadence shifts, prosody shifts, all those things. Most speech generation engines, including ours at the present moment, although hopefully not for too much longer, that's not how they work. They are basically generated without that context. And this is why most conversations right now, they start to feel quite flat after a window of time. So you've probably noticed this, where the first time you talked to a voice agent, let's say with an 11 Labs voice, you were like, wow, this sounds so good. It's so realistic. And then I'm guessing after you talked to it for a little bit longer, you started to think, why does this sound wrong? Like it's a little bit flat. It's a little bit monotone. Like you were really impressed at the beginning. And by the end, you're like, it kind of sounds like a robot. And like, why is that? Well, I think it's because we don't have this conditioning that's live in the call. And I think that's the thing that's missing right now to unlock that we've been working on for some time. And I think we'll have something hopefully fairly soon for that. But for right now, whether you clone a voice or use existing, you're going to have the same problem because it's the same underlying approach. And until we change that approach, I think it's gonna be kind of the same.
Okay, and that flat tone, how will you change? Like, for example, put it in the prompt, or using a better voice, or just cloning your voice?
So I think right now there is no way to change it for what's available, because it's just how the models work. And you can write as many prompts as you want and it won't change anything. I think that in the future that will not be the case at all. That you will be able to influence it via prompting, but also the model will be able to sort of dynamically adjust in the call relative to what's happening, just like humans do, right? Like you'll probably notice, okay, in this call, I'm trying my best, by the way, because I'm guessing most of your listeners are not native English. They're probably native Spanish speakers. And by default, I'm a very, very fast talker. So this is my typical speed is more something like this. And so I'm trying, and even for my team, it's very fast here. And so like right now, I know I'm trying to like slow down my speech a little bit, just because I think it'll be easier for people that are not native English speakers to follow. Like, these are choices that we make as humans in context of the call. We need the LLMs to do the same thing at the end of the day. And that's what you should expect over the next couple of years. Like, as we get to it, like, to answer your question, like, what it allows us to get to human-like level conversation, we have to solve these problems. If we don't solve these problems, we'll never get there. But again, I'm very confident they're going to be solved.
Okay. In fact, in case you want to share it, what are the key priorities of the main roadmap for Ultravox in this 2026?
Yeah, I mean, there's always like a set of things that we are always working on. Number one is we're always working on like the performance of the Ultravox model overall. Like, I want to make sure that it's and I'm gradually trying to get to increasingly human-like level of quality of conversation. And so that tends to be like three things when I break it down that I think about. Number one, how do I make sure that the model always understands what's being said? There's all kinds of real world situations out there. I'm on the bus, I'm on speakerphone in the car, I've got background speakers, the radio's on, the TV's on. How do we train Ultravox to be more and more robust against these real world use cases? Because these don't bother humans, so it doesn't need to bother the model. The second thing is that, like, how do we get increasingly realistic speech generation on the other side? So that thing we were just talking about. So that's been a big priority for us. And then there's a lot of stuff in the middle for, like, how do we make the conversation feel incredibly natural? So, like, one of the things that we do as humans is that we back channel. Like, that's like the term. And back channeling is like, yeah, like those things that we give. And how do we have the model? So number one, how do we understand those back channels from the human? But number two is, how do we start to get the model to emit those back channels? And I think to do that, there's a very dumb way to do it, which is like just guess and have the model inject. This is like what some platform, but it's very terrible. The better way is to have the model learn it. And that's what we're working on right now. And so basically we're working on a full duplex answer that I think we'll have an answer for in the coming months. So those are the big things for us. And of course, we're always working on platform features, reliability, scalability, things like that. But like, my goal is always to keep us fast and keep us the best. And so I spend all of our time on that.
That's amazing. In fact, what are these coming next in the upcoming Ultravox? I mean, the updates. What are we gonna see?
Well, things around this. I think you should expect better speech generation soon. I think you could expect some better conversational experiences. I can't tell you timelines and exactly, but I can tell you that this is what we're working on, and hopefully very soon.
That's perfect. In fact, anything else would you like to share?
I don't think so. I mean, like, I appreciate you taking the time, and I think these are great questions. I think it's I think in general, all model progress in AI is continuing to accelerate. And I think that's true for LLMs as well, or for voice agents as well. And so I really encourage people to be thinking about, you should look at what's happening at the forefront of text land and be thinking about, like, what do I bet on in voice line that's going to like put me in a best position to leverage those capabilities. And so I know, just I encourage people to be thoughtful about that. I think I think speech to speech is coming and evolving very rapidly. The component pipelines are stuck. They will never get better. They're basically as good as they'll ever get. I think speech models can continue to get better at a rapid rate. So I'd encourage people to try those if they haven't yet. It doesn't have to be Ultravox, Gemini, OpenAI Realtime, Soniox from Amazon. There's a bunch of them. So I encourage people to give them a try to start familiarizing themselves with their own quirks. Because I think that's going to be the future for sure. There's no doubt in my mind.
Okay, so thank you so much, Thak. I hope to see you again here. Thank you.
Yeah, thank you, Sergio. It's great to see you, man. And I look forward to chatting more in the future.
It was amazing to have this chat.